In the year since Dolly the sheep was cloned, 64,000 biologists and doctors have signed a statement opposing human cloning. It's illegal in Britain. America's professional body for doctors working in reproductive medicine has imposed a 5-year moratorium on research.
Nevertheless, Dr. Seed claims to have a team of doctors ready to clone a human, to be negotiating with the Chicago clinic, which has all the equipment, and 4 couples from Chicago are apparently willing to take part. Number 1 on the list, he told the Boston Globe newspaper, is a married, upper-middle-class couple who are both infertile. He wants to clone them both to give them children.
But the man who cloned Dolly is suspicious of the argument that his technique would help couples who are both infertile.
What you're suggesting is that a couple like that the wife might have to live not only with her partner, but also with a little copy of her partner. And I think that would make a very unusual and unsatisfactory arrangement for all 3 of them. So it to me doesn't seem to be a sensible idea. We could go through all of the particular cases if you like, but I still personally have not heard of a suggested reason for copying a person that I find ethically acceptable or useful.
Did you know, through bioengineering, scientists have created multiple different forms and types of new animals? For example, have you heard of a zorse? A mix between a horse and a zebra. It's real. This is an example of genetic enhancement. Is genetic enhancement, along with cloning, ethical? What are the benefits and risks of human advancement using CRISPRing, AI, and synthetic biology? Today, we delve into the depths of cloning, not just as a scientific marvel, but as a gateway to broader ethical questions brought forth by advancements like cloning, CRISPR, and other genetic engineering technologies. As we navigate this complex topic, we'll ponder the implications of manipulating human and possible animal tissues. Are we on the brink of redefining what it means to be human? Should we limit our focus to human cloning, or should we expand our scope to encompass all aspects of genetic modification and enhancement? These questions and more. Join Paul Root Wolpe Ph.D. from Emory University, the Center of Ethics, and I as we embark on a journey through the realms of science, ethics, and the very essence of life itself. Join us as we get rebelliously curious. Paul, thank you so much for joining me on Rebelliously Curious today. You are the director for the Center of Ethics at Emory University. Before we get into the conversation of CRISPRing, cloning, AI, and all of these advanced technologies, can you tell me a little bit about Emory University and what you focus on at the Center for Ethics?
First of all, thank you for inviting me on. I'm delighted to be here. Most of the centers that deal with ethics in the United States are bioethics centers. I spent, in fact, most of my career, or a large part of my career at the University of Pennsylvania at the Center for Bioethics. What's so fun and interesting about the Emory Center for Ethics, it's got a very major and important bioethics program. We've got a master's degree in bioethics. So we do all of the medicine and life science ethics. But we also get to do legal ethics and business ethics. We have an incredible ethics in the arts program. We do civic ethics. We do the ethics of almost anything. We dabble in journalism ethics and sports ethics. So it's really a wonderful platform, and there are not very many places like it in the United States that have this comprehensive approach to ethics.
What's the difference between cloning and CRISPR?
Cloning is the process of taking a totipotent cell. That is a cell that, if it's implanted in a uterus, will evolve into a full organism, whether it's a sheep or a human being, taking that and duplicating it so that you get a second organism exactly genetically identical to the first. That's what cloning does. And you could do it again and again and again and get multiple individuals that are exactly the same. CRISPR is a way to take those billions of base pairs in that genome that you're replicating and cloning, clip out a piece in the middle and put something else in it. So you're not replicating the entire organism when you use CRISPR. You're changing one or maybe multiple traits of that organism. Then if that organism reproduces naturally, the next organism, if you did that in a germline, I mean, if you do it in cells in my cheek, it won't happen, will replicate that change. But that next generation organism is not going to be a clone of me. It'll be my child, just like I have two children, would be one of them. But they will have this change in some part of their functioning. So cloning is global. It replicates an entire organism. CRISPR is changing some specific genetic trait about that organism.
This is a big question to ask off the hop, but how do you view the evolution of man and where we are now currently in contrast with how we view bioengineering? And are we on the right path?
One of the things that's true is that technology changes our view of ethics. First of all, because it raises new questions, but also because it changes the environment in which those questions are asked. And I think a way to approach this, before I get to answering your question specifically, I just want to say a word about ethics, because I think most people misunderstand ethics and what ethics is. And I think the reason for that is that we're taught about ethics incorrectly from the time we're young. We're taught that ethics is about trying to discern right from wrong, what's right and wrong in any situation. And yes, that's true, especially when we're young. We have to be taught the basics. Don't steal, don't hit your sister. But once we get those basics down, ethics is rarely about a right versus wrong. What ethics is almost always about, and if you and your listeners think about times that they had ethical challenges, it is almost always about two rights in conflict, not a right versus a wrong. And the reason for that is that what ethics actually is how we think about, negotiate, assess our values in the world. So, for example, I teach medical students. We give them cases. Patient wants you to do X. You think what's in the best interest of the patient is Y. What do you do? Now, what's the situation here? Is there a right versus a wrong? No, you've got two important values: patient autonomy, your responsibility to do what's in the patient's best interest, and they can't both be satisfied. So the truth of ethics is that ethics is about how we express values in the world, and ethical dilemmas are about what we do when those values come into conflict, which means that there are a range of possible good answers to an ethical dilemma. There are also some really bad and wrong answers, but you and I might disagree about what the best answer is, and we could both be taking very defensible ethical stances. So I like to say that what ethics is about is not figuring out what the right answer is. It's figuring out what the best right answer is. That is, amongst all the possible things we could do here that are defensible, what do we think is the best thing we can do here? And wrong doesn't really come into it unless we've got, I think, a very, very problematic view of ethics. So with that as a quick explanation, what happens over time is that values change and they evolve. I'm asked sometimes, are there different values? Are there different ethics in times and place, or is there one ethic for all time and place? And the answer to that is yes. That is, there are the same ethical issues from the beginning of human history, issues of duty and honesty and loyalty and issues of transparency and fairness. I mean, we could list all of those values. But what happens over time is that the way we weigh those values when one is in conflict with another changes. The way, we think of group good versus individual liberty. That's what most of politics is about. In the United States, we go heavily on the side of individual liberty. Another country could go much greater on common good. That doesn't make ours right and theirs wrong. we're weighing these two things over time. We're weighing these two things against each other. And over time, our weight might shift. We might decide, well, you know, we were a little too far on the side of individual liberty. Let's kick up common good. And that's how, and if you add 50 other values, all of which are moving up and down in that sort of schema of time moving, ethics evolves. So when we get a new technology that changes things, when we get computers and the internet and the web that changes the way we communicate, our values around communications change. And so when we begin to get technologies that allow us to manipulate the very plasms of life, our values around what life is, how we think about life, they don't change fundamentally. We still deeply value life, et cetera. But the way we look at it changes somewhat. You know, when we lived primarily an agrarian life, our attitude towards animals were very pragmatic. As we moved into urban modern society, animals became pets. Most people don't have direct relations with farm animals. We get our meat on a shelf in a supermarket. Our attitudes towards animals changed. And then at some point, ironically, they started to move towards greater animal rights. So when we move to things like cloning and genetic engineering and other ways that we change the human being, they are shifting our values towards them.
So how do we collectively then evaluate ethics? Like, I know you're saying that, but like when we're looking at multiple different countries, especially now, we live in such a polarized time. How do we come together and have those conversations about ethics and then bioengineering and then cloning and CRISPR and all of those things? How do, you know, is there a process that's done within academia along with then politics where we're able to sit down and have these conversations together?
I wish it were quite that neat. These conversations are messy. I mean, every conversation at the water cooler on a Tuesday afternoon between two workers bringing up cloning is part of the conversation. That is, these conversations are collectively negotiated by society. Yes, there are the experts who try to put them into formal recommendations. That's what ethicists do. We write lots of papers saying, here's what you should do. We don't have any power at all to make people do those things. We just, you know, give it our best argument. And then policymakers read those papers perhaps, or call on us to testify and get those opinions, and may make the laws. But those laws are always under review and are a reflection, hopefully, of the general public attitude towards these things. And so all of society, in that same sort of way that I'm talking about values being shimmering measures against each other, society's conversation is one giant ball of millions of conversations that, through the magic of social life, generates collective ideas about things. And those ideas can be corrected over time. When Dolly was first cloned, there were all kinds of crazy ideas about what cloning was. And, you know, Saddam Hussein creating armies of cloned soldiers. I read an article about that at that time. And something like 90% of the American public was not only against cloning, they were against cloning animals, they were against cloning anything. You fast forward a year or two after people started to understand what cloning was, the issues around cloning animals begin to decline considerably, so that by a few years afterwards, people are fine with cloning animals, but still very much against cloning humans. So these conversations happen collectively. They self-adjust over time, hopefully. They reach policymakers who we hope reflect the educated public opinion about these things, and then we adjust them over time. You're absolutely right. That's become much harder to do around certain issues. And that's because we've stopped talking to each other. And part of that is technological. The advent of social media has not brought us closer together. It has created pockets of social media in which we reinforce the beliefs we already have, rather than creating sounding boards where multiple beliefs are aired out and debated. Part of what we try to do at the Center for Ethics is to create safe spaces and curated conversations where people who have different beliefs can come together and talk. And in fact, I'm going to be stepping down as director of the Center for Ethics June 1st. And in the next 3 years, I'm building a new center at Emory for conflict resolution, civic dialogue, and peace building. So this very problem that you've described is what I plan to spend the rest of my career working on, which is how do we have conversations about really tough issues in a mutually respectful and open way.
That's amazing. Right now, with what's going on in the world, it's very, very needed. So I commend you on that for sure. It's it's so ironic to think that social media is creating that divide when you would hope that it would bring us together to have better ethical solutions on dilemmas that could advance us in society and as humans. It's sad to see that. Yeah.
It's a profound irony because it has the capacity to do the first. And at the beginning, it did. I mean, when people first started using Twitter and social media and Facebook and those things, it was a window to other worlds. It was fascination of watching people who lived very differently than you or who had very different opinions than you, giving you an access we hadn't had before in the same way. And it is largely the fault of the platforms themselves that they found that the best way to sell things, to maximize their advertising revenue, was to make people feel good by reinforcing their prejudices. And so, as we all know, people began to just see reflected back at them the kinds of things that they put out. So, if you gave money to a Democratic candidate, you only started to see Democratic feedback, and if Republican, the same thing. And we've actually allowed our new technologies to reinforce the polarization that we all say we don't want.
It's unfortunate. Maybe one day we'll be able to separate those, and here's hoping. Before we get into human cloning and CRISPR and genetic engineering in general, can we talk about what was the first genetic engineering that humans were doing? And I believe it was Dolly the sheep. I believe it was in 1998. I might be wrong, but can we start with where we started with animals and then where we are now?
So we've been manipulating the genomes of animals for thousands of years. Selective breeding and other techniques have been used to try to create the kind of animals that we want. The Bible tells stories about selective breeding. So we've understood, even before we understood what a gene was or that there were genomes, that there were heritable characteristics that we could manipulate in plants and animals. It was only in the 20th century that some of the more sophisticated ways of doing that began to arise. So if you think about selective breeding, you have to go through natural gestation cycles. So in an animal, it could take years to create a trait that you're trying to reinforce. And that was the way it was done up until modern times. Dolly was not the first cloned animal. Oh. Dolly was the first cloned mammal. We had been cloning non-mammal animals for a long time. The physiology of mammals was different than reptiles and amphibians and fish. And there were technical barriers not worth going into here that made it very, very difficult to clone mammals because of the way our cells divide differently. While Dolly was a shocking moment to the public, it was an expected moment in science. That is, there had been a lot of people trying to break that barrier of mammalian cloning, and people in the field knew it was going to happen sooner or later and that we were close. So it wasn't as shocking within science as it was outside of science. However, science did a singularly poor job in preparing the public for that moment. People knew nothing about it. And this is worth taking a step out of your question for 1 second to point out that one of the things people don't remember so much now, because it's very different now, was that in the 70s, 80s, 90s, scientists were considered to have diminished themselves or stepped out of their role as scientists if they talked to the public. Scientists who were in front of cameras were considered to be wasting their time. Those who became very popular public spokesmen, the Carl Sagans of the world, were considered to be sort of pandering to the public and, abandoning their scientific role. There was no classes taught or lessons taught in graduate programs about how to talk to the public about science. And that impoverished the scientific conversation. If what I said was true, that change happens through those conversations at the water cooler, if they have no idea what's happening in science, then they can't have those conversations. And I think that Dolly was an important moment in that conversation also, not just an important moment in science, but an important moment in public understanding of science, because the backlash to that took scientists by surprise and made scientists realize that, this was just another step in the long history of trying to clone animals. And it's a great one, while the public went into this kind of international hyperventilation about cloning. And you got these articles with these crazy theories. And, there was a cover of the New Republic, a slide of which I used to show all the time in my talks, which was this very strong article by Leon Kass, who was the head of President Bush's Bioethics Commission, about the, terrible human violation of cloning human babies, something that, 40 years later, we're still not doing. But he wrote that article as if it was happening tomorrow. And we couldn't. I mean, we didn't have the technology. There, cloning non-simian mammals, that is, non-apes, is different than when you step over into chimpanzees, humans, or orangutans, because there is a difference in how our cells divide too. And that gap wasn't solved for years and years and years. So we couldn't have cloned human beings then, and we weren't even close to it at that time. But there was this fear that was brought out about science run amok. And I think scientists began to realize, first of all, we did a really bad job preparing people for this. And second of all, we really need to talk to the public more about what we do. And I think that was the beginning of a change. Scientists are much, much more willing now, those who are interested in it and talking to the public. Scientists who do talk to the public are no longer seen as lesser than, or people who have sold out, because I think now it's really important for the public to understand what some of these technologies can and can't do. And now we're having that same conversation, by the way, about artificial intelligence and ChatGPT and all of these non-biological technologies, but still very much in the same vein. So once we started cloning animals, then we had a number of interesting questions to ask. Look, our relationship to animals over, the centuries has been pretty, bad in terms of its moral stance a lot of the time anyway. But the idea that we could manipulate animals directly, that it won't take years and years and generations, but that we can directly intervene in the genome and do what may have taken 20 or 30 generations in selective breeding in the equivalent of one generation, meant that we had to ask some serious questions about what our proper posture was towards manipulating animals and using animals. Speed is an ethical issue, and people don't think of it that way. But the ability to, if it takes 20 generations, you've got a lot of time to think about it. You've got mistakes along the way that you can correct. You've got, directions you can redirect. If you can do all that in one step, you've lost that contemplative time and you've lost those corrective possibilities. And so cloning became a lesson, not only about talking to the public, but about how we should think about our relationship to animals.
Yeah, there's so much to unwrap there. First, with animals, we look at cloned animals, or sorry, not cloned, or bioengineered animals, such as like the zorse and the beefalo. And is the beefalo even a consumer product now?
Yes, you can get beefalo patties if you want to. That's buffalo and cattle. Some of these are engineered. Some of them are really just sort of forced cross fertilizations. There are many different techniques they use to create these hybrid animals. Some of them even occasionally occur naturally. Yeah, there's a blurry line between those kinds of manipulations and direct genetic engineering. And there's one not so blurry line. It doesn't matter how many times you try, you cannot crossbreed a deep sea jellyfish with a rabbit. But you can take a gene, a bioluminescent gene out of deep sea coral or a deep sea fish and put that bioluminescent gene into a rabbit and have a rabbit that glows. We've done it. So genetic engineering allows not only cross-fertilization of relatively closely related species, but it allows the mixture of genomes of species that have absolutely nothing to do with each other.
Wow. Scary. Just a little bit. Can be very exciting and very scary how you view it.
Yeah.
We were talking about the evolution. So the evolution of bioengineering, looking at engineering babies, where are we on that scale? Because I remember in 98, I was young then, but I remember this time of seeing so many news clippings and information about cloning in this, as you were saying before, everyone having these conversations and worried about it. And it was really forefront in the media. And then we looked at potentially different countries saying that they had cloned children and that there were cloned children, from specific cults, I believe, that said they were in the scientific community, all the way then down to actual scientific community. So where are we now since 98 or even before that with cloning humans?
So you're right, there were a lot of claims being made. There was a scientific group called the Raelians who had claimed to have cloned some people. Of course, all of that was nonsense. It was just a way to get on. But in fact, and then sort of cloning isn't so much what people talk about anymore. Cloning kind of evolved into this general genetic engineering, and especially when CRISPR came in and genetic engineering became much more accessible. A couple things to say about that. First of all, people often ask me or try to make the argument that at one level, at least, ethics is ineffectual, and that is, we can come up with all of the ethical standards we want, but if someone wants to violate them, they will. And one of the ways I try to show them that there can be power in ethical consensus is around this very issue. So it has been a number of years since we've been able to genetically engineer the human germline, to create genetically engineered babies if we wanted to. And as far as we know, it's only happened really once. And that was He Jiankui, the Chinese scientist who claimed he tried to create some human beings born more resistant to AIDS. And he was roundly internationally condemned. His scientific credentials were taken away by China. I mean, of all places, China, where they have often not bought into the international consensus around certain ethical principles, and have, tried to take the lead in certain scientific areas where in the West we're much more hesitant for ethical reasons. They arrested him, they put him in jail. So we have come to an international consensus that genetically engineering the human germline is ethically unacceptable. And that has been generally adhered to internationally now for many, many years, which shows that there are ethical principles that we can all agree on and that we can use with only informal enforcement. Now, that enforcement ends up being a little bit more powerful than people think, because one of the other truths about the world, even in the midst of our polarization, is that we have become a much smaller, more globalized, more intimate world. And what happens anywhere, we all know about immediately. And the scientific community has become an international consensus community. Science is done globally. And so if you want to be part of the scientific conversation, you want to be accepted into international scientific meetings, you want to have your papers read and accepted at journals, you can't do rogue things that the international community think of as unethical. So in fact, I think China's reaction to He Jiankui was a reflection of the internationalization and globalization of the scientific enterprise, in that to be part of that global conversation, you have to generally adhere to a set of ethical standards. So that's why there has not been sort of rampant human cloning and genetic engineering. Now, there is a lot of genetic engineering going on in individuals that don't affect the germline. That is, that just affect my body, but not my offspring. The key with the ban is that we shouldn't clone we shouldn't genetically engineer embryos or clone embryos, and that whatever genetic changes we make will then be passed on from them to their children and their grandchildren and great-grandchildren. On the other hand, we're getting much closer to trying to making the plausible argument that, especially for health situations, we might want to loosen those reins. And you're beginning to see experiments come out that are much closer to genetically engineering embryos. I mean, after all, if we have embryos, or we even have developing fetuses that are showing signs of really significant genetic disease, and we can go in and intervene, the argument goes, why shouldn't we? And the argument before that was primarily a safety argument, though there were other arguments as well. And the safety arguments are beginning to get less compelling as we get better and better at doing these technologies. And if you look at early cloning, if you look at the cloning of Dolly, you would usually have hundreds of mistakes first. And people don't care that much if you have hundreds of mistakes in malformed sheep. But even a handful of mistakes in human beings is not acceptable to us. So that's part of the evolution of these technologies, is can we get them to the point where they're reliable enough that we won't have significant collateral damage of various kinds, whether it's a problem we can anticipate or a problem not. So, for example, CRISPR does create many of those kinds of problems, but there are newer technologies that are more precise. It's sort of the next generation after CRISPR is now being developed. And, it'll be an interesting moment when we're finally at that space where there's a technology that someone can argue is strong enough and direct enough and powerful enough that it could be argued that it won't, or it can be reliably used enough that the compelling part of it to cure disease or stop some really bad process of genetic mistake, that the trade-off is worth it.
Yeah, and standardizing. That's something that I've always maybe had a fear. And maybe you can clarify this for me. I think a lot of people probably have this question too. When we look at standardizing something like CRISPR and moving it into the healthcare system, let's just say in a Western perspective right now, right? Not an Eastern perspective, but standardizing it and putting it into our daily, when before children are going to be born, knowing that this is what we're going to be doing, taking out certain health related issues, maybe mental health, who knows with that, where we might go with that. And then looking at changing even what they look like, from hair color to eye color, and customizing that. Do we get into a place where we become that in the general healthcare system, that this will be standardized, and that instead of having vaccines or something else, CRISPRing is mandatory no matter what? And then, we look at other things like potentially, this is a little far out, but Neuralink, when it gets to a certain level that we're able to standardize that. Do we get into a place that's so, sci-fi futuristic, where we're using CRISPRing in the beginning, and then when a child is born, we're using a Neuralink? to increase productivity or anything else, or, throw us back into the system, I would say. Are conversations like that being had right now? I know it's such a futuristic thing, especially with Neuralink,
No,
but CRISPRing's not far away to be standardized, I would think.
we've been having those conversations for years. First in science fiction. I read a lot of
Right.
science fiction as a kid, and science fiction, for those who don't read it, is a very moralistic genre. That is, science fiction stories are almost always about some profound moral dilemma of technology or of something, or even the ones about meeting aliens are about the moral question of what being human is and all of that. And then it moved into sort of the ethics realm when it moved out of the realm of fiction and into the realm of reality. And so we've been writing, I mean, one of my colleagues at Penn wrote a book called The Perfect Baby back in, I guess it was the late 90s, maybe early 2000s, on all of these questions, and that was almost 25 years ago. So we've been asking these questions for a long, long time. And the questions haven't really changed. But as I say, technology changes the ethical calculus. So, for example, if you look back into the 90s, you have books that came out about psychotropic drugs, right? Drugs that change our brains. And you had Listening to Prozac, and you had Prozac Nation as two examples of books. They're basically saying, are we all going to end up taking drugs to micro-manipulate our mental states and, take a wake-up drug in the morning and a drug after lunch for our sort of postprandial nap, and it's really interesting to look now at what's happening 20 years, 25 years later. Microdosing and the legalization of marijuana everywhere, and people being able to get drugs off the web where before they had to walk in front of a physician and ask for a prescription in ways. So that reality is coming true, but as usual, in a very different way than they predicted. Because what they predicted was that physicians were going to turn into lifestyle consultants, and you would go into the physician and he or she would have this panoply of drugs, and they would say, okay, take 3 of these and 1 of these. And that's not what's happening. It is because of the internet is becoming consumer based, it's becoming individualized, and with the Viagra and drugs focused on sexuality, that quickly moved out of the doctor's office into a consumer space. And so we have to ask the same question about these kinds of technologies. Right now, you still have to be pretty sophisticated. You still have to have a nice lab to do a lot of these things. But what people didn't realize about CRISPR that made CRISPR such a revolution was not just how much better it was at genetic engineering than most of the techniques that came before, but how much easier it was than techniques. A really smart grad student with basic materials could genetically engineer plants and small animals. That is, we're just emerging into the era of we are now in the era of do-it-yourself medication, and we're going to enter an era perhaps of do-it-yourself genetic engineering. And do-it-yourself genetic engineering might mean creating your own pet. It might mean creating your own plant variations. It might mean, lots of companies, and these companies already exist, companies that will create microorganisms on demand for industry. We need a microorganism that eats this byproduct of our manufacturing plant so it doesn't. And there are companies right now that will manufacture that bacterium for you.
Wow.
And so we're entering a very different age, not just of what the technology can do, but the social organization and the industrial organization of genetic engineering as a manufacturing and private process. And insofar as I'm arguing that the evolution of technology changes our ethical calculus, the way in which we see these things is going to change in the same way that microdosing, and by the way, it's not just microdosing. At Emory, we now have a program that looks at the use of psychedelics for therapy, right? 10 years ago, that was so far out that people were doing it, but you wouldn't see it at a Harvard or Emory necessarily. You wouldn't see it at the top institutions. And now it's everywhere. LSD and other drugs that were seen as recreational bad things are now being recognized as therapeutic agents and are being normalized. And marijuana is now normalized. And so the question becomes, socially, how are these technologies going to be normalized and integrated into sort of the everyday workings of our lives? And they will be.
Gosh, there's so many things I still want to unpack when you make these comments. Back to, I'll say, the manufacturing and doing it at home, the biohacking, because biohacking's already been starting at least for the past 5 years that I know of.
Absolutely.
And that's being able, people doing it at home, but it's been not very safe and regulated. So a little bit scared about that. Then I would say the next thing I want to unpack from those comments is about society and us being able to do it ourselves and having that ability to do it. Will that solve then the disparity gap that we see within economics that could come from this? Because it's right around different countries, especially with different nations that are developing, they won't have those abilities potentially. And even let's just say within our own like cities, like I live in Toronto, we might have an issue too with obviously disparity gaps that we see, especially what's happening now in our climate. So does that help to solve it where it's be able to consume in a larger level where pharmaceutical companies or other companies will be able to come in and offer that for people instead of then just creating a massive gap where it's only for the wealthy?
Yeah. So all new technologies create a disparity gap. And in my view, a disparity gap that is going to happen in the development of a new technology is not an argument against developing the new technology. It's an argument for how we apply that new technology. The good news about this is that those gaps are diminishing much faster these days when new technologies come out than 100 years ago. That is, we spread technology much better now than we used to. Cell phones are very expensive items, and yet almost everyone, even people who one would imagine would not be able to afford that technology, given what a sophisticated technology it is, have cell phones in the United States and throughout the world. And we were in China, my family and I, and there were rice farmers with yaks or whatever those large animals were out in the rice fields with cell phones on their belts. So part of the question becomes, and by the way, in general, as Steve Pinker has argued, poverty overall is decreasing. Those gaps are decreasing. In fact, the funny irony of all of this is the great gaps seem to be becoming less between what we might think of as the middle class and the poor than of the sort of upper middle class and the super rich. That's really where the big gaps are these days, the Elon Musks and you and me versus, you and me and someone who works a minimum wage job in a, developing, in a poor resourced country. Not that those gaps aren't still there and they're still worrisome and things that we have to work on, and there's still real poverty in the world, and I'm not trying to minimize that at all. But if you look at the trends globally, you see these shifts. What we didn't mention at the beginning of the podcast is that I'm a sociologist. My PhD is in sociology, so I tend to think about these things in social trends. Part of the promise of modern technologies in general, not just biotechnologies, is that they will diminish gaps. Part of the arguments that are made by a lot of the tech startups is that this tech startup will help, bring together poor and wealthy. There's a lot of social entrepreneurship that goes on in the tech world. That being said, to move to the other part of your question, yes, the thing that scares me the most in the world of the technologies we're talking about is not what's going to come out of MIT. That's carefully regulated. It is looked on by institutional review boards. It's under some NIH, it's what's going to happen in, metaphorically speaking, somebody's garage. That is, these technologies are becoming so easily used. I have argued that the science that goes on in an 8th grade classroom right now is science that the greatest scientists in the world couldn't do 25 years ago. These technologies, these manipulative technologies, are going to be in kits that middle school kids can use to change moss from green to blue. I made that up, but I mean, ways to manipulate plants and animals and mosses and things like that is going to be something so easy and regular that anyone will be able to do it. What kinds of pathogens are going to be created with someone just messing around with a bacterium and then create some new form of disease, or someone working on some plant or soil bacteria and creates some new toxin or toxic process. That's really what scares me a lot more than sort of the bioweapons on a grand scale, because those will be accidental and perhaps uncontrollable. So yeah, there is a lot to worry about in the power of these new technologies.
Yeah, and you mentioned bioweapons. That was something I wanted to talk about, is the technology, and especially in defense, where
Yeah.
countries around the world, I agree, Joe doing chemistry and biohacking in his garage
Yeah.
is petrifying, but I'm also scared that Joe might find something and decide to send it to somebody, to another country that obviously won't is not an ally to us, right? Or to any other countries, and cause a lot of social issues. So where are we with that, with when we look at biohacking along with then bioengineering within defenses right now, and these conversations with all different military industrial complexes happening around the world?
I mean, those countries have their own Joes working in their
For sure.
lives to find
For
things,
sure.
right?
Yeah.
So it's an interesting paradoxical question about that. See, here's the thing about bioweapons. If I create a new pathogen or something that can cause disease, in our modern world, as we saw with COVID, disease is almost never restricted to a single geographical region. So if I'm going to loosen a disease on my enemy, sooner or later, it's going to come back to me. And so that's sort of, as funny as it sounds, that's the good news. The good news is that there are disincentives in many ways to create really, tough, deadly bioweapons unless they can be the kind that are well contained, like poisoning someone's local water source or something that won't necessarily move out to come back to bite me. And that's why right now we see less sort of international activity around that, though I am sure there are labs in every country working on this in secret. And you get a much bigger bang for your buck with hacking into systems from a computer hacking level. You can do a lot more damage closing down someone's electrical grid, and that's not going to come back and automatically close down your grid. They may try, but I mean, it doesn't spread the way bioweapons could. So, it's a very complex issue, but there is no doubt that these new biotechnologies make the creation of bioweapons much, much easier. And it's very scary.
A lot easier. Now, what about the conversation of AI now within bioengineering? Like, what it's going to learn. We know that Q-Star right now is learning mathematics, and it's scary on its own area right now with that developing. So where are we when it comes to then combining both of those areas? Are we creating these mutant superhumans then?
We are. I mean, there's there's still a lot of debate about where AI is going to go and what its limitations are and what we mean by superintelligence, and Nick Bostrom's idea that we're, James Burnett wrote a book called The Final Invention because he says, AI is going to take over and we're going to become secondary or obsolete, creatures on this planet. And, how do we answer the question of, do we listen to AI programs once they gain the capacity to understand things that are beyond our understanding? How do we even question them in the kinds of conclusions they might come to and recommend for us? What does transparency mean in a system that's smarter than you when you can't understand? We're all talk about transparency and explainability in AI. We need to know how it comes to the answer it comes to. Well, what happens when AI's processes become so far beyond our understanding that we can't understand, even if they're transparent, the way AI came to the conclusion that it came to? So these are all really tough questions about the limitations of human agency, about the question of what happens when we, as the most intelligent creatures on this planet, are no longer the most sophisticatedly intelligent creatures on this planet. And will there be a kind of cyborgian element to this? That is, will we try to somehow incorporate or integrate AI into biological, physiological mechanisms? Or will AI evolve as a separate mechanical, non-organic form? I don't know. I mean, nobody knows. There are a lot of things to worry about in those. I mean, for the last 6-7 years, almost all anyone wants me to talk about are the ethics of AI. All of these really interesting things that you and I are talking about, that I talked about for years and years and years, people are not asking me those questions very often anymore. What they want to know about is AI. And it makes sense because AI has exploded. I mean, ChatGPT was like Dolly. For the people in the field, they knew it was coming. For the people out in the world, it seemed to come out of nowhere. They knew about AI, knew it was doing things, and all of a sudden, this AI appeared that you could ask any question to, and it would give you these incredibly sophisticated answers. And it brings us back to the original question. These new technologies are going to change our value systems around them. And I'll give you one quick example. I wrote an article recently for the Hastings Center report on the fact that questions like privacy and plagiarism, those were the two examples I used, are going to fundamentally change their nature. They have to. Both of them, in the way we think about them today, are products of the late 17th century into the 18th and 19th. Plagiarism didn't exist really before that because things weren't mass produced. So when people wrote things, they were hoping other people would copy them and even put their name on it. They didn't care. They were just interested in getting the ideas that they created out there. Since they couldn't be monetized, they didn't care that much about credit. It was only in mass production of intellectual property that people first began to care about it as something I could own, because now I can make some money off my books, right? And so plagiarism became this byproduct of that. Well, now with cut and paste and mashups and this sort of ubiquitous availability of intellectual property and ChatGPT, which draws from everywhere, what does it really mean to have intellectual property anymore? And what does it mean to plagiarize? And what does it mean to copy? And that is fundamentally changing. And those of us in the academy are having to ask ourselves the question, what do we teach about plagiarism now? What do we expect from our students? How do we handle ChatGPT when we assign a student a paper? Do we let them use it? Do we not let them use it? Do we try to use it with them and discuss what's theirs and what? I mean, these are all questions that are changing the way we think about intellectual property because the technology is. And I think the same thing is going to happen in ways we can't even imagine right now, both in the biological realm and in the AI realm. As these technologies get more and more sophisticated, there will be combinations of technologies. We're going to use AI to create new bio creatures, whether they're, on the macroscopic or microscopic level. And we're going to use AI to create new bioterrorist pathogens also. And so these technologies are going to be intertwined for the rest of our days.
I'm just happy that I am the age I am now because I might not be around. Maybe when it's full force, who knows? Just saying that. But getting into the conversation of then, yeah, in the future, how do we then? I'm assuming people are going to have these existential crises if they're not already having it now to some
Yeah.
degree. How how are you viewing that from an ethical perspective? You know, how do you talk to people based on how they view themselves when it comes to AI, especially when it comes to now CRISPRing, and then what the future will look like, and then what their genetics and what their history and their familyhood and everything else that's in that genetics, because we know that genetic trauma is true. You know, we might be taking that out. You know, how are people saying then, like, does it matter I exist? What does my existence mean? And then what is my existence when I lived here to go on in the future with my
Yeah.
children and everything else? Is that just going to disappear?
That's a great question. And I think the answer is it might. I mean,
Oh, no.
I know it seems quite tragic to us. The example I like to use is what's happening with gender and gender identities now. I mean, if we could pull someone from the 19th century, they would be astonished, aghast, and outraged. I mean, people in the 21st century, many of them are astonished, aghast, and outraged, but they wouldn't understand the whole evolution that led us up to the idea that gender identities could be fluid. Now, there were some societies where they were more fluid, and there were third and fourth and fifth genders in certain societies. But as a global conversation, there was still a binary assumption. And so the increased fluidity of gender is itself that same kind of evolutionary process, perhaps. And so there are a lot of cultures and religions and societies that think of individual identity as an illusion anyway. And that it's ego that keeps us wrapped up in the idea that I exist as an independent individual entity with a personal identity that is itself somehow sacred. And in fact, in Western religions, that's codified as a truth. But in certain Eastern religions, it's just the opposite. And so is it going to end up that these technologies erode that sense of individual identity in a new way? I think it's probably likely. And humanity will evolve into that new model in some way. It scares us because that's not the model we know and believe in. But it doesn't necessarily mean the end of some of the basic values that we carry into that model any more than then, as I said before, though, the balance of how we weigh these values may change over time. The values themselves maintain. So we will see.
We've seen in history that genetics have obviously been passed through generations. And we can see that now by looking at people's DNA. But when we get into CRISPRing, we stop that. Like
Yes.
that could be all taken out. Now,
Right.
I guess back to
Yes.
that. Is that even ethical then?
So
Because
that's
then, yeah, because I would find that that's kind of a hard place where we're making like distinct changes and choices, not just evolution-based changes over time. Or is this our evolution? Is science and CRISPRing our form of evolution too?
Yeah.
It's such a challenging question.
It is really challenging. I mean, is the heritability of the human germline itself a sacred thing? And certainly in
Yes, yeah.
Western religions, it is considered that way. But science has shown us that our genomes are a mishmash of Neanderthal and other humanoid genomes, of viral DNA. I mean, our genomes aren't these sort of pure human passed on things that we think of them as anyway. And maybe one of the lessons of modern science is that, those things aren't as important as we thought they were. Again, we can weave ethical stories about these things, and they tie into longstanding traditions. But like so many other things that have had to change in religious belief to accommodate modern reality and modern truths, maybe that is just another one that's going to have to change. In my tradition, I'm Jewish and I work in Jewish bioethics. There's a long history of the question of what do we do at the very end of life when someone is imminently dying? And there's a whole long thousands of years conversation about what you can and cannot do in someone who's imminently dying, which for 99% of that conversation meant within a couple of days. There were no ventilators, there were no respirators, there was no way to keep people alive for weeks, months on edge. So now all of a sudden the technology has completely changed dying, and now modern, Jewish and Muslim and Christian scholars saying, well, how do we think about these century-old ideas about what is ethical about dying at a time when dying has completely changed its nature? And we're going to have to ask those same questions about all of human development that changes its nature based on technology, and whether the ways we've conceptualized and the ethical principles we have put into those things over the centuries are still valid and relevant.
Wow. My last question to you. In the center of ethics, I imagine what people are saying and talking about what the future will look like. But what do you personally think that the future will look like with genetic engineering in the next 50 to 100 years?
From the beginning of the human experience, humans have tried to change themselves, their physiology and their functioning. Every society we have ever discovered uses makeup, piercings, tattooing. Every society we have ever discovered drinks teas and choose plants to change their mental functioning. Human beings have, and by the way, every society uses tools to change their spears to extend their ability to kill. And, if you lose a leg, every society creates some kind of crutch or prosthetic. So we as human beings, for our entire existence, have been creatures that changed ourselves in the pursuit of some theoretical desire we had, whether it's to extend our ability to extend our senses, whether it's to change our mental states or our physical states. We now have tools that can do it with incredible precision and sophistication. We will use them. We will use them sooner or later. We always have, and we always will. So I think if we could fast forward 50 years, human beings are going to look different. I think that people are going to customize various functions that they have in various body parts in ways that, I'm not sure we can really even quite imagine, except in, multiple science fiction scenarios where we try out different ways that might happen. We can see it already in the incredible body shaping technologies that some people are using to change, putting, splitting tongues and sharpening teeth and tattooing faces and putting little prosthetics under the skin and things like that. I mean, these are still relatively marginal, but as those technologies become much, much more available and sophisticated and simple, the human shape, the human function is going to change in ways that I'm not sure that we can imagine today.
Whew, that's a great way to end it. A little bit of fear, a little bit of excitement, a little bit of excitement. I am looking forward to maybe seeing what we will hopefully evolve and look like, and how hopefully health standards will evolve. That's something I'm looking forward to, CRISPR. So thank you so much for being rebelliously curious with me today.
It was a great pleasure talking to you.